In the far distant past, a predator roamed what would eventually become northern Wyoming. For unknown reasons, the animal died, or was possibly even killed, before it was fully grown. 150 million years later, a small team of scientists and volunteers discovered these remains and have been working to put them on public display. This is the story of Caesar, the Sheridan College Allosaurus.
You know, it's a funny story, actually. It was about 6 months after I'd started work here. We did there was an election in 2010, in November of 2010 for trustees, and we elected several new members to the board, I think 3 new members to the Board of Trustees. And so what we do when we get a new trustee is we do an orientation program, and part of the orientation is a tour of the campus. And so I actually ended up in a part of the campus I had never visited before, which was our science museum. And we had some folks over there who had arranged to be there in advance and took us through and showed us all the different things in the museum. One of which was all these different parts of a dinosaur called Caesar, the Allosaurus. And about 2 months after that, maybe 3 months after that, we were very lucky to get state funding for 50% of a building project which we'd had on the books for a number of years, which was a renovation and an addition to the Whitney building, focused on science, technology, engineering, and math. And so I had Caesar in my mind, and then we had this opportunity to build a new building, and built around the idea of serving the sciences and our students in the sciences and upgrading our classroom capacity. But one thing that I was quite certain of is we want to make sure we can try to find a place in this new building for Caesar. So we began having conversations around the community. I think it was that spring of 2011. Our first major donor, which was First Federal, came on board with a $50,000 contribution, and so we knew that we were actually going to be able to make it happen. And from there, it was you know, just doing the physical work of getting the dinosaur cast and getting him situated in his new home up on that mezzanine where he can overlook in the distance where he came from.
In about 1990, 93, I filed for a state permit in Johnson County on Section 36, and it's down south of Crazy Woman Canyon. A gentleman from Minnesota was working in what they call Poison Creek Quarry, and that was being taken out. They were going back to Minnesota due to the cost factor. Long distance, they had quite a few people. Erickson, his name was, and Professor Erickson invited me to come part of the time with them on the last year they were there in 1989. And he said, Michael, you ought to take over the permit in this area. There's a lot of dinosaur bones still here, but we have all we can take back to St. Paul. So we would take students out there, show them Caesar's bones in the ground. Brian got upset every time I brought students there. Dad, somebody's going to dig it up. We got to get that thing up.
For a long time, my dad conducted a trailside lecture. It would incorporate the whole square mile at the state section there, and included not only just the main quarries, but there were a lot of other geological locations along the way. There was some petrified wood. He would talk about the stratigraphy, and one of these roadside or trailside stops was this 2 metatarsals sitting in some sandstone, and he talked about this. They were in situ, and that they were notably important because they were theropod.
Brian said, Dad, you got to dig this dinosaur up. There's a dinosaur underneath these 2 metatarsal ankle bones. And I said, well, Brian, okay, you've talked me into it.
This was our first actual skeletal material from a carnivore. So we knew not only for display-wise it would be significant, but also for science this would be significant. And it took a couple of years, but I convinced him to actually begin an excavation there. And for an 11-year-old boy, this was a dream come true.
And Caesar started coming out of the ground.
Caesar was an Allosaurus, and Allosaurs were these 2-legged carnivorous dinosaurs that looked a lot like Tyrannosaurus rex. But whereas T-Rex lived during the Cretaceous about 70 million years ago. Allosaurs like Caesar lived during the Jurassic, which is about 150 million years ago. Of course, now during the Jurassic, Wyoming looked a lot different than it does today. Wyoming, for one thing, was flat. You didn't have these mountains yet. They hadn't formed. And so you've also got all these slow meandering rivers that are flowing from here north to an inland sea up where Canada is now today. The continents were all in different places as well, and so you had a lot higher sea levels. You didn't have any polar ice caps because the climate was a lot warmer. In this part of the world at that time, you had these two distinct dry and wet seasons, sort of monsoonal. But with all this moisture and this temperature, you had these really lush forests of ferns and like horsetails that were massive, like the size of bamboos. You didn't have flowering plants yet, so you had these gymnosperms, these like pine forests. And so these are the sort of plants that all the herbivore dinosaurs are eating, like the sauropods, the ones with the long necks and long tails, like Diplodocus and Brachiosaurus and Apatosaurus, which used to be Brontosaurus. And you've got others though too, like Stegosaurus, and those are the ones that have the plates on the back and the spines on the tail. But it was the herbivores that on the land that Caesar would have been feeding on. These dinosaurs that were living at this time period, some of them, when they died, became fossilized and ended up in these rocks, primarily the Jurassic Morrison formation, and that's where the Sheridan College dinosaur quarry and the rocks that we excavated Caesar out of came from.
The first material that was fully exposed that we uncovered at the Allosaurus site was the pelvis. And because I had taken to calling all the other specimens in the lab names that I thought were appropriate for their size or their shape, I thought, well, we found the pelvis, we've got to call him Elvis. And Mike Flynn said, oh, come on, Jessica, we can come up with something that's a little bit more dignified than Elvis. And so I thought about it, and I thought maybe Caesar would be a little bit more appropriate for a fossil that carries this much weight, because it's pretty important.
We know that he was not fully grown when he died. We don't know exactly why he died. The only clue that we might have is on his arm there's this really substantial gash, which looks an awful lot like maybe the tooth of another carnivorous dinosaur. So we don't know, maybe he got into a fight and he lost, but it's also entirely possible that he just ended up being fed on after he died. But the preservation is really pretty good. The unfortunate part is that some of the bones were really close to the surface, so roots got in there and they kind of played havoc on some of the bones. But the ones that didn't are really nicely preserved. They have a nice brown color and preserved a lot of detail. There's a fair amount of him missing, which is unfortunate. He's only probably about 40% complete. So while we have representations of most all of his bones, there's some stuff that's missing, like most of his spine from his neck down. We have a good chunk of his tail, but unfortunately a lot of the backbone is gone. And so the other bones are sort of broken up and they're there, but they need a lot of reconstruction, which is what Michael Holland has done with them. And for that, what he's done is he's taken another famous allosaur, which people have probably heard of, called Big Al, which came actually just from the other side of the mountain, and is about the same size, in fact, as Caesar. So he's going to be able to take replicas of some of those bones and fill in the missing parts of Caesar, and should make a really impressive looking mount for back at the college.
And so what I've done here is actually based on bird behavior. And this is what I'm calling an avian threat or intimidation posture. If you watch birds when they're interacting with each other, either with a scenario like two birds of the same species, maybe facing off over territory or resources or something, or in some cases even maybe birds of different species where one of them is maybe being threatened by the other one and is trying to kind of defend against that, they all kind of seem to have this similar attitude that comes over them where they kind of plant their feet and stand their ground, and they lower themselves. The body just sort of drops. They get kind of down in a pose that would suggest that if they wanted to jump or suddenly spring into action, they could do that. The head usually goes down kind of low and out. A lot of times beak opens up and they start making all kinds of crazy noise. And usually they move their head in these kind of movements, sort of tossing it around a little bit. The tail goes up and back behind them, and the wings tend to go out. So that's kind of what we've done here. We've got the arms out and back a little bit, and then we've got the head lower than the hips, and the neck is definitely extended. The vertebrae on these guys, if you look at the centrum, the body of the vertebrae, they have a really pretty steep angle on them, and they're built that way so that the neck can have this nice recurve to it when the animal's just relaxed. But when they extend out, they have quite a reach. And so we wanted to kind of show that. And so we brought the neck out and the head forward. And then by putting it down, we kind of got a little extra added bonus in terms of spectators, because rather than having the head somewhere up there where you might kind of get lost in the lights or whatever, you know, we put it right here. For me, I can see a lot of it, but I think even someone smaller than me, even you know, a kid could come up here and still get a pretty darn good glimpse at the animal. And if you're tall enough to get directly in front of it and look into the mouth, you can stare straight down the gullet of an Allosaurus, and I think that's a lot of fun.
One of the big issues that not only this college, but every college in America faces right now is the fact that we are falling further and further behind the rest of the world in college completion. For most of the 20th century, the United States led the world in the percentage of adults who had completed college. Today we're 16th in the world, and falling fast. And that has just tremendous implications for the future of our country in terms of, if you think about all the things that followed from that generation when we were first in the world in college completion, the kind of economy we had, the kind of entrepreneurship, the kind of civic engagement. And so we've got to do more to, maybe entice is the right word, to entice especially young people to be interested and excited about college. So the first thing that this artifact is going to do is, I mean, I really can see and hope to see every fifth grader between Rapid City and Billings coming here in an orange bus on a field trip. And you know, we were all excited about dinosaurs as children, and so maybe bringing younger people into the college, getting them excited about an education built around science, for example, is one way to sort of connect the next generation with pursuing a college credential, which is really, really important for the future of our country.